Here's pre-calc problem 10-52. It says sketch a hyperbola centered at the origin with focal points at 0, 3 and 0, -3. Mark a point P on your hyperbola and label it with the coordinates x, y. So I think the problem I was having with these, they're going to keep asking you this. The problem I was having is that I didn't know how you could really sketch a parabola without already knowing, figuring out A, B, and C. But now I think I know the intention of the problem. What I think they want you to do is realize that since you have focal points, you know that you can at least draw an XY graph, and they gave you a center and 2 focal points. So even though you don't know how big to draw that box that you draw with the asymptotes, you can just sketch, because it does say sketch. You can just sketch like a fake hyperbola that doesn't, that's not really accurate, but at least you can have, the general shape. And then they want you to go ahead and find, what A and B are by doing this derivation. So, and I've done this in other problems. I'm going to try to make it a little more clear this time. So the thing with the hyperbola is, the definition of the hyperbola is that it has a constant distance. D1 minus D2 is always a constant. So no matter where I go on the hyperbola, the distance, the sum of the distances, how can I say it? This distance minus this distance, they're always going to be the same. Like in this problem later on letter B, they tell you that it's 5. Okay, so that's just the definition of a hyperbola. Well, we have a distance formula, and I went all over this in the lecture video. The distance formula comes from Pythagorean theorem, but basically I can get this distance by going y2 minus y1, or yeah, y2 minus y1, and square it, because that's like Pythagorean theorem, and then x2 minus x1 and square it. So on letter A, they ask you to go ahead and just show an expression for the distances. How do they say it? Write an expression for the difference of the distances from point P to each of the focal points. So I just want the difference of the distances. So I just plug in my distance formula. Okay, and then I can just call this one, I called this one D1. And I didn't have to put my point P there. I could have put it there or somewhere on the parabola. So then I wrote down my empty distance formula, and then I'm going to fill it in. Well, I guess you can see the pencil where I filled it in. I'm just using the ordered pairs to fill it in. See, there's my -3 and my y. I hope you can see that. And so fill it in. So this one is, I'm doing this little distance right here. So it's like y2 minus y1 and x2 minus x1. Okay, so that's what they want for letter A. They just want you grab the distance formula, plug your ordered pairs in there. And then for letter B, they tell you that if the difference in the distances from any point on the hyperbola to each focal point is 5, use this distance with your expression to create an equation. So now it was an expression because it didn't have an equal sign, but now I'm just going to take the exact same thing and make it an equation with an equal sign. And then they say, letter C, they say, see how far you can get rewriting your equation from part B in graphing form. So this is some gnarly algebra, but I think that you guys can do it. You just have to make yourself sit there and do it, but I think that you have the knowledge to be able to do this. It's hard to not make a mistake. I did some of it in pencil because I make mistakes too. So these are my, oh, So I skipped some steps, didn't I? These are my expressions. Okay, so I went from here, and I square things out in my mind. So if I were to square this, it would be negative 3 minus y times negative 3 minus y. So I can use an area model box. I'll do it one time, and then I'm going to do it in my head the rest of the time. So if I went negative 3 minus y, negative 3 minus y, then this gives me a 9. That gives me 3y and another 3y and a y squared, and that would all come out to y squared plus 6y plus 9. Okay, there's my y squared, my 6y, my 9. Okay, and then that is just, that just gives me an x squared. Okay, so that's what I'm doing every time I see one of these binomials that's squared, I'm squaring it out, but I'm not writing the box. You might need to write the box, but basically you can take the first thing and square it, and then you take the first thing times the second thing, and double it, because see how there's always two of them, and then you square the last thing. So we can do this. So all I did is squared out these little binomials in here. And then here I squared out these binomials. I took the first thing squared, first thing times the second thing times 2, and then the second thing squared. And then x minus 0 is just x, so that's x squared. And so there we are, our first step. Okay, now I'm just doing algebra. And where am I trying to go with the algebra? I'm trying to get right here. I want it y squared over something minus x squared over something equals 1. Okay, so here I am. Now what did I do? I thought I would I want to get one of these. See how I have a square root minus another square root? I want to get one of the square roots by itself so that I can square both sides of the equation. So I subtracted, I added this piece on the right-hand side, and now I'm going to square both sides. When I square this left-hand side, it just gets rid of the root. So see, as everything's the same, but I just get rid of the root. And then when I square the right-hand side, I just have a binomial to square. And so it's the same thing we've been doing. I just go the first thing squared, and then the first thing times the second thing times 2. So 5 times this radical times 2 gives me 10 with the big radical. And then I square the second thing. Well, all that does is gets rid of the square root sign. See, these are all just what was inside here. And so then I can go through, at this point, I just want to clean it up. I don't want to write everything all down. So I see there's 9s on both sides of the equal sign. So I subtract 9 from both sides. I can subtract y squared from both sides. I can subtract x squared from both sides. Let's see. I want all the variables on the left and all the constants on the right. So, oh wait, no, what do I want to do? Let's look and see. I want to, well, first I guess I just got rid of all the things that I noticed could cancel out. And then I went ahead and added the 6y to both sides. That's how come I got a 12y here. And I subtracted 25 on both sides. Oh yeah, because I got to square this out again, right? Because we can't have this radical in here. So I need to get everything that's not the radical on the left-hand side. I considered dividing both sides by 10, but I saw that it would give me decimals, so I'm just going to square out that 10. So now I'm going to square both sides. Now this is just a binomial again that I can square. So I'm going to take the first thing squared. First thing times the second thing, it turns out 12 times 25 is 600. Times 2, or 12 times 25 is 300, times 2 is 600. And then 25 squared is 625. And then I square the right-hand side. Well, that just turns this into 100, and it gets rid of my radical sign. Okay, then I can distribute 100. And then I can look at it again and see if there's anything I can do. So what I did here is, I think I looked at the x squareds and I said, in my mind, I just subtracted 100 on both sides. So that gave me 44y squared. And then I see this negative 600y. I can just cancel the whole thing out. And then I see my 625. I wanted to subtract it on both sides. So 600 or 900 minus 625 gave me negative 275. And then I'm going to subtract 100 x squared on both sides. So that's how come it's over here now. And then I look at it and I see that I have all my variables on the left and I have all my constants on the right. And I know that I'm trying to get to here. So I need a 1 over on the right-hand side. So I want to divide both sides by 275, negative 275. If you don't like fractions, you're not going to be very happy with this. And then, so this gets really weird. This just turns into a 1. This one, I want the y squared on top and some decimal thing on the bottom. So I multiply, well, how can I say this? I want to divide the y squared by 44 over negative 275. So instead of dividing, though, it's easier to flip and multiply. So the reciprocal of this is 275 divided by 44, right? 275 divided by 44. So you just go 275 divided by 44. That gives me 6.25. And it's going to be negative. Okay, so there's that. And then this one, these are going to cancel out and make it, it's going to be positive. The reciprocal of 100 over 275 would be 275 over 100. And it's going to give me, we're just going to leave it as a decimal. So it's 2.75. And then I let them switch places, and there's my hyperbola. And then if I did want to go back and fix up my graph, I could. I don't think it's really important to fix up my graph because I don't think they were expecting me to. I don't think the point of the problem was to get an accurate graph. I think the point of the problem was to derive the equation. So I'm not going to go back and mess with my graph. I'm just going to be happy that I derived the equation.